Okay, the last thing we need to talk about here is if you wanted to find the sum of an infinite geometric series. So infinite means it goes on forever. So far, we've talked about geometric series that are finite, like they start and they stop at a certain number, or they go for so many terms. Like we've had find the first 5 terms or find the next couple in your sequence. Those last couple of problems that we were dealing with the summation, we were adding all the terms together in our sequence. We're going to talk now about how to find the sum of an infinite geometric series, which seems almost kind of impossible. Okay, because if it's infinite, that means it goes on forever and ever and ever. Okay, but it is actually able to be calculated. We can sometimes find the sum. Now, this chart kind of goes over that for us. Okay, so it says that in an infinite geometric series, with your first term, A1, if the common ratio, so the absolute value bar of it, is less than 1, then it has a finite sum. So it means that there is possibly an end because the numbers are going to start to get so small that they start to approach a certain common number. Think about like those exponential graphs that we saw a while ago when they slowly get closer to the x-axis, that kind of stuff. If r is greater than 1, we can't do this, okay? So only if your ratio, your common ratio is less than 1. So that means that we're dealing with like a half, a third, a fourth, something like that. If it's greater than 1, it doesn't have a finite sum. And so an infinite series that has a sum is said to converge to that sum. So like I said, it kind of approaches to a specific number as it gets smaller and smaller. When an infinite series does not converge to a sum, then it's known as it diverges. So an infinite series can do one of two things. It can either converge to a common number or it can diverge, which means that it's not possible to find it. If it converges, that means that your r is less than 1. If it diverges, that means that your r is greater than 1, and it does not have a sum. Infinite means no limit on the number of terms. Okay, and so we're going to look at 3 different geometric series to see what's happening here. So series number 1 says that my first term is a 2 and that my r is a 3. So my ratio is a 3. That means that they're multiplying by 3 every time. So they took 2 times 3 to get 6. They took 6 times 3 to get 18. 18 times 3 to get 54. That's where they're getting these numbers from. Okay, and then what they started to do is add them together. So the 2 plus the 6 is how we got 8. 8 plus that 18 is where we got the 26 from. Adding 54, we got 80. So you can see how this number, as we continue to add another element, is going to continue to increase. Okay, because the radius, I'm used to geometry, but because the ratio is 3 greater than 1, that means that this sum is going to continue to increase and increase and increase over time. So we're not going to be able to find the limit. So the first series does not have a limit. So this one here, for series 1, has no limit, so it's considered to diverge. The next one, we're still starting at 2, but this time my common ratio is a fourth. This is less than 1. So this means we're taking our numbers times a fourth. So we get a half, an eighth, and 1 over 32. This time as you start to add, you can kind of notice that the numbers are progressively getting a little bit bigger. Okay, but look at the decimals. They don't really seem to change all that much. They're getting closer and closer to 2.6 repeating. If I kept going, if I took 1 over 32 and I took that times a fourth, I'd get something smaller here, but it would still be 2.6 something. And if I kept going, these numbers would all get really, really close to 2.6. This is like that exponential idea where it's going to come down and it's going to approach 2.6, but it's never actually going to probably go below that. So because my ratio is less than 1 this time, it's a fourth, it does have a limit, which appears to be about 2.6, so it would converge. So this would be for the second one, this series here. The last one, we're still starting at 2, but now my ratio is a negative 5. This means you're taking everything times negative 5. So we get negative 10, 50, negative 250. Again, because it has a ratio that's greater than 1, it has no limit, so it diverges. So the only time you can do these is if you have an actual ratio that's less than 1 is when you can find the finite sum. Okay, so let's do an example here together. I want to find the sum of the infinite series if it exists. So only if it has a ratio that's less than 1. So I'm going to look at my numbers. I've got 8, 4, 2. Remember, to find your common ratio, to find your R, you put the second term over the first term. So 4 over 8, how would that reduce? 1/2. Okay, so that's what they have here. They're saying R is 1/2. That means that it's less than 1. So a sum does exist. So to find it, we can use that formula from the chart up above. So our formula says this: A1 over 1 minus the common ratio. A1 is your first term in the series, which is what number? 8. And what's my common ratio? What did we say R was? 1/2. So you're going to take 8 divided by 1 minus 1/2, or you're taking 8 divided by 1/2, which is? I think you're right, Breck. Oh, what'd you say? Oh, not 4. $16. That's what you were going to say, right, Fabian? Yeah. 16?
Is this 6 7 from yesterday?
No, it's back there in my tray on the right. Middle kind of row, far right tray. Okay, let's do one more here. Okay, 1 minus 1/3 plus 1/9 minus ... We want to see if we can find the sum. So first thing we need to do is find our common ratio. So we're going to take the second term, which is a negative 1/3, and we're going to divide by the first term, which is a 1. What would be anything divided by 1? Yeah, it's just whatever the number is. So negative 1/3 divided by 1 is just negative 1/3. Okay, again, my absolute value here of this is what they really want me to focus on. That's still just 1/3. That's still less than 1, so a sum will exist here, which means we can use that formula from the other page. So we're going to do 1 over 1 minus negative 1/3. And that 1 on the top came from the first term. That's where that came from. That's A1. And what do you get when you do this? .75. Questions on using that formula to find the sum?